Alright, so section 2.5, we are still going to talk about inequalities, but now we're amping it up a little bit. So this is solving and graphing compound inequalities, which means we're going to be looking at more than one piece of an inequality. So our essential question asks us, how can you solve a compound inequality, and how do we graph it? So what do we graph? Alright, and a couple vocab, just three of them. Compound inequality just means we got two or more simple inequalities put together. Okay, intersection means the overlapping region of the simple inequalities graphs. And let me just say that the intersection is actually going to be our and. Okay, we're going to talk about what and means later. And our union is the combined regions of the simple inequalities, which is going to be our or, which we're going to talk about later. So just to start off, we haven't really reviewed graphing simple equations, so that's what I wanted to do first. I wanted to look at these two, and I wanted to just review what do we even do to graph a simple inequality. So these are some simple inequalities. We've got two of them here, and we're going to look at them. So this first one says x is less than 3. So 3 is going to tell us something. 3 is going to tell us about the end point. What is our end point? Alright? The less than is going to tell us something. It's actually going to tell us two things. It's going to tell us the shading, and it's going to tell us whether it's an open versus closed dot. Okay. So the shading portion is going to be what's true. So we're going to shade on this number line where it's true. So if we let's just think through this first one. If we plug in 0, 0 is greater than 3. That is not true, so we do not shade it. 1 is greater than 3. Not true. We do not shade it. 2 is greater than 3. Nope. 3 is greater than 3. Nope. 4 is greater than 3. That's true, so we'll be shading in here. 5 is greater than 3. That's true. So we will be shading in that direction, okay? But now we have this end point at 3, right? That's what we said, that's our end point. But we said it's not true, so we can't actually shade it. So what we do is we represent it with an open dot, okay? So to give you some, so let's keep that there, and then we'll look at this one, then we'll make some generalizations. So let's think here, x is less than or equal to 2. X is less than or equal to 2. Alright, let's just start over here. Negative 2 is less than or equal to 2. That's true. 0 is less than or equal to 2. That's true. 2 is less than or equal to 2. 2 is equal to 2, so that's true. But then if we get over here, 4 is less than or equal to 2. That's not true, so we can't shade anything on that side. But we did say 2 was true, so we're able to shade that with what we call a closed dot. Okay? So this is actually the graphing of these two simple inequalities, but we've got to make some generalizations. So we've already said that the number is going to give us our endpoint. But what do our endpoints look like? So we've got two different types of endpoints. We've got a closed dot, right? That's what we use down here, and what we call an open dot. And they both are used at the endpoints. The closed dot is going to be used when we have less than or equal to or greater than or equal to. So whenever they can be equal to that number. The open dot is going to be used for less than or greater than, as we saw up in this first example. So that's kind of the generalization which you need to have in your notes for the two dots and which one to use. Alright, and if we look at the direction of the shading, just to kind of make a little bit of a generalization, this is pointed, if we make it an arrow, to the right, so we shaded to the right. If we make this into an arrow, right, this is just temporary, if we make it into an arrow, it's pointed to the left, so we shade to the left. Okay? Alright. Also, I want to mention, and these numbers on your number line, because that's what we're using, these numbers could be any numbers that you want. You could have put in negative 100, 10, 25, as long as they're increasing as you go from left to right. but you want your endpoint to make sure that it lies sort of in the middle, right? Here I went by 2's, but as long as my endpoint lies in the middle, we're good. Okay, so let's do some complex inequalities. Well, no, before that, I want you guys to practice with these. I want to make sure you can do simple, because if you can't do simple, you're definitely not going to be able to do complex. So on the left-hand side, go ahead and make sure you graph and, so graph these. X is less than 10, x is greater than or equal to 6. Make sure your number lines are big enough, right? You can use any numbers, but your 10 just has to be the center of it. Awesome. Okay, if you're not done with that, go ahead and pause the video and complete those. Okay, if you're back, I'm assuming you've already completed those graphs and you're ready to move on to the complex inequalities. So the first thing that we're going to do is we are going to cut out a chart, which is on page 82. There's a chart at the top of the page, and you're going to paste this chart in the right-hand side. This chart is right under the solving compound inequalities involving AND. So I'm going to title our next section, AND inequalities. AND inequalities. And we're going to look at those first. So if we think about our AND inequalities, those are the ones where we're seeing an intersection, an overlapping region. So the first one we're going to look at is x less than 4 and x is greater than or equal to 2. So now that we're complex, we're looking at complex things, we have 2 endpoints. We have 2 endpoints. Okay, so we'll look at our number line, and all we need to make sure is that these endpoints lie in the center of our graph, or around there, right? And it's increasing. So we'll start with 2, 3, 4, 5, and we'll go 1. Making sure that 2 and the 4 are in the center of our number line. Alright, so let's do the first one. X is less than 4. X is less than 4. Okay. So I'm going to do, you know what I'll do? I'll do one in red and one in purple. And then we'll see where they overlap. So in red. X is less than 4. So here's our endpoint. If we look back at our little cheat sheet, it should be an open dot because there's no line underneath it. There's no equal to. And if we make this into an arrow, it's going to point to the left. Okay, I'm just going to graph the whole thing and then we'll look at the overlapping region. Right? And now let's look at this one. X is greater than or equal to 2. So this needs to be a closed dot because it has a line underneath it. It can be equal to, and it needs to be shaded in this direction. Right? Make that into an arrow, it's pointing to the right. Okay, but we only want the overlapping region. We only want the stuff that's both red and both purple, which is this stuff in here, right? That's the only stuff we want to include. So if we look at an, I'm just going to bring a number line down here. 1, 2, 3, 4, 5. Okay, we only want that overlapping stuff. So at 2, it's a closed dot. At 4, there's an open dot. And in between is where we shade. That's how we graph our complex and inequalities. Awesome. Okay. So I'm going to erase this. Actually, no. I'm going to show you one more thing. One way that you could also rewrite this, since it's an and inequality, is you can write these together. So you could write it as x is between 2 and 4. Between 2 and 4. Okay, remember though that it has to have a line underneath for the closed dot and not a line underneath for the open dot. So x is between 2 and 4. Awesome. So I want you guys to try one on your own. If you still need this, just pause the video. Alright, the one you're going to try is x is greater than 6 And remember, because that's all we're working with so far, x is less than or equal to 10. Remember to use those as the center of your number line. Don't use 1 or 2 as the center. Use 6 and 10 as the center. So pause the video, do that on the left-hand side, and then we'll come back together. All right, if you are back, I'm assuming you've already completed this on the left-hand side, so I'm going to erase it. And we're going to look at a little bit more complex of one. We have negative 5 is less than or equal to 2x plus 3, which is less than 9. So notice the two signs, right? The two different inequality symbols, and we've got a complex inequality. So what we're going to do is we're going to break this into two different pieces so that it's simpler for us to solve. First piece is going to be negative 5 is less than or equal to 2x plus 3. The first piece. The next piece is going to be 2x plus 3 is less than 9. That way we have two simple inequalities to work with. And we're going to solve these out so that we get x by itself so that we can actually graph them. So we're going to circle the term with x and solve from there. So on this, if we're working out this problem, the first thing we want to do is subtract 3 on both sides. We get negative 8 is less than or equal to 2x. Okay? Now I'm just going to look over here for a second to notice the exact same thing. We're going to do subtract 3 on both sides, which is exactly the same thing as we just did. So 2x is less than 6. Alright, and then if we think about trying to get x by itself, we notice this is multiplication, so we need to divide by 2 on both sides. This is multiplication, we need to divide by 2 on both sides. We get negative 8 divided by 2, we get negative 4, less than or equal to x. Over here, x less than 6 divided by 2 is 3. And there's our two simple inequalities that we need to graph together. Alright, so this is quite a bit of a span, but I need to make sure that negative 4 and 3 are the center of my number line. Those are my endpoints. So I'm going to go negative 4, because that's the smaller, and I'm going to put 3 over here, 0, negative 5, 6. So as long as they go in order, you've got your endpoints, that's all that matters. And let's graph from here. Alright. Negative 4, that's our endpoint. That has a closed dot. Why closed? Because there's a line underneath it. It can be equal to. For 3, there's no line underneath it. That's an endpoint with an open dot. From right there, since you know it's an and inequality, you can go ahead and shade in the region in between. Okay, let's just check. Let's just check one of these randomly from in between here. Let's check 0. 0 is an easy one to check. So the shaded region should be the true region, meaning it works. It's true. So in order for us to do that, I'm going to go ahead and erase this. Right, if you need it, just pause it. And we're going to try out the number 0. So we're going to try 0, see what happens. Okay? So we're plugging 0 in for our variable, which is x, and we get negative 5 is less than or equal to 2 times 0 plus 3 is less than 9. Okay? So negative 5 is less than or equal to 2 times 0 is 0. 0 plus 3 is 3. Less than 9. And let's see if this is true. So 3 is between negative 5 and 9. Okay, that's true. It's less than 9. It's more than negative 5. We're good. Awesome. So there's our and inequalities. So the one I want you guys to do, complex one that looks like this. So you're going to follow the same steps we kind of just went through. And you're going to complete it on the left-hand side. Is going to be negative 10 is less than 3x plus 2 is less than or equal to 8. So you are solving it first. You're solving it in two different processes, and then you are graphing it. So do this on the left-hand side. When you're done, go ahead and come on back. All right, if you're back, I'm assuming you completed this. So that is the end of our and inequalities. So we're going to move on to our or inequalities and looking at some different kind of graphs. So our ors. So the title of this, we're going to have or inequalities, which we talked about in our vocab as being a union. So the combined region of the simple inequalities. So the combined, so there's going to be two regions in this case. So if you guys could please cut out the chart on page 83 on the bottom of the page. And you're going to put it on the right hand side underneath the or inequalities. When you're done with that, you can go ahead and come on back and we'll start our first example. So the first example we are going to do is going to be 2x is less than or equal to 6, or, so that's what we're working on, 3x is greater than 12. Cool. Okay, so we got to solve these guys. We got two simple inequalities, shouldn't be too hard. We've got 2 times x. Okay, well, to undo that, we got to divide, just like we would an equal sign, and we get x is less than or equal to 6 divided by 2 is 3. Or, if we solve this one out, just like we would an equal sign, we divide by 3 to undo that multiplication, and we get x is greater than 4. Okay, cool, so we've solved them out. Now the last thing we've got to do is just graph them. Okay, we just got to graph them. So we're going to make sure that these are still our endpoints. These are still our endpoints, so we've still got a centrum on that. So we'll have 3, 4, 5, 6, 2, 1. Alright? And we're going to do some shading. So let's do this one first. 3 is going to be our endpoint, and since it has a line underneath it, since it can be equal to 3, we're going to use a closed dot. And it's less than or equal to 3 if we drew this as an arrow, right? Points to the left. So that means our shading is going to go to the left. And we can check any of these numbers. 1 is less than or equal to 3. That's true. Check any of them. They should all work. For this side, our endpoint is 4. But this symbol, this greater than symbol, means that it's going to be an open dot, not equal to. And if we make this into an arrow, it points to the right, which means that we shade that direction. And this is what our OR graphs are going to look like. There's 2 different regions, right? Here's one region, here's 2 regions, but they get graphed on the exact same number line. That's what our ORs look like. That's what a union looks like. Okay, so that should have been on your right-hand side. Now the one that I want you to complete on your left-hand side is going to be 4x minus 1 is less than 15, or x is greater than or equal to 48. And you're going to graph those out. Awesome. So pause the video, complete those on your left-hand side, and then come on back when you're ready. Okay, if you're back, I'm assuming you completed these 2 on the left-hand side, and I'm going to erase this. And we're going to go into our last set. So our last thing is creating inequalities. So actually writing them from a graph. From a number line graph, like we've been looking at. Okay, now I want you guys to cut and paste these from your notebook. So we have on page 86, you're going to have number 9 is going to be pasted on the right-hand side, and number 10 is going to be pasted on the left-hand side. Okay. Alright, so for number 9, what we are doing is we are looking at this number line that's got 2 endpoints. Right, I'm not going to draw on the exact number line they have. You guys have it in front of you. negative 10, negative 8. I'm only going to include some of the numbers. Negative 5, negative 3. I know you guys have more on yours, that's fine. 0. Alright, and then it has 2 exclusive dots with shading in between them. That's exactly what your graph should look like on your right hand side. This is number 9 that we're looking at. And we're trying to write some sort of inequality. So the very first thing we need to decide is whether it is an and or if it's an or. So is it an overlapping region or is it a combined region, meaning there's 2 sections? Well, there's only one section, right? Only one shaded area, which means it's overlapping area, which means it's actually an and. So with an and, what we can do is we can always start off by saying x is between, we still need to decide if these have lines underneath them, and then the 2 endpoints. So we've got negative 8, okay, there's one endpoint, and negative 3, there's the other endpoint. Okay, we just got to figure out, do these have lines underneath them? Well, these are 2 open dots, and if we look back in our notes, we should see that the open dots never have lines underneath them. Therefore, this is actually our final answer of how to write an equation from that number line right there, or how to write an inequality from that number right there. Another way you could write it, just because I want to be sure I'm showing both methods, is you could take each one individually. You could say x is, right, well you would think, that's the way the arrows would be pointing, that's the way their shading is. So x is greater than negative 8, and let's try and do this one, x is less than negative 3. Either one of those answers are perfectly acceptable and perfectly okay. Alright, so you guys need to, the very last thing you need to do is do number 10 right here on the left hand side. Once you've completed number 10, you've completed section 2.5 and you are done with this video.